Hello and welcome to Unit 3.3, Deductive Reasoning. Now, deductive, you're going to come to a definite conclusion, with inductive not as definite. Okay, so where are we? Introduce inductive reasoning, which is the process of deciding something is true based on a pattern. Okay, in deductive reasoning, we're going to start with a true claim, and then we're going to build an argument to prove it. So we're going to start with that, like my name is Myra. And how do I prove it? I have a driver's license with my picture of my name on it. I have credit cards with my name on them. I have all these documents with my name on them. Hence, if I'm carrying them and it's my picture and it says it's me, it's me. Okay, so we're starting with the truth and then proving it, backing up statements. Okay, a mathematical proof is a sequence of statements. Now, there's a given or an axiom, which is kind of like a postulate. Don't worry about that. There's a given. Then there are postulates, which are things that you can accept without proof because they're like obvious truths. Then there are theorems. Theorems you use logic to prove. Okay, so, and in a two-column proof, which is what we're going to do most, you can use statements and reasons to back up and prove what you're trying to prove. Okay? And here's a sample proof. Okay, now you notice angle A and B. Notice they're marked with this little square. That means they are 90 degrees. We good so far? Okay, so statement, angle A is a right angle. How do we know that? It's in the given. And if it's in the given, you have to accept it as truth no matter what. Angle B is a right angle in the given. Could you put these two in one sentence? Yes, absolutely. I often do that. Okay, the measure of angle A is 90 degrees. All right angles measure 90 degrees. B is 90 degrees. All right angles measure 90 degrees. A has the same measure as B. 90 degrees equals 90 degrees is what I would have said here. Okay, but that's a simple two-column proof. You make a statement, you back it up with how you know. Okay, we good so far? If you have any questions, stop the video, write them down, or if we're together, just ask. Thank you, thank you. All right, here's a model problem, and I know that this looks like the stuff we did when we were doing a different chapter. We had to figure out the lengths. This is a little different. All right, if B is between A and C on a line, everybody see that? We have a line, and B is in between A and C, okay? If B is in between A and C on a line, then AB plus BC equals AC. Okay, AB plus BC equals AC. Okay, that's the segment addition postulate. We're adding segments. Okay, and now that we can use that, now that we know that, we can use it in a proof. Let's see if I have the proof on the next page. Yes. All right, so now they do the proof a little differently than I would, and that's okay. Because if we did the same thing again, we'd do it a different way, and that's okay. All right, so B is between A and C, given from the diagram. You see the diagram, A, B, C. B is in between. Okay, AB plus BC equals AC. That's the segment addition property. And now that they call the next thing addition, I call it subtraction. Either one is fine, because you're adding the negative, whatever. So AB plus BC minus BC equals AC minus BC. And then when we simplify, okay, BC minus BC goes to 0. I don't have to write plus 0. We have AB equals AC minus BC. And they call that the additive inverse. Yeah, I call it subtraction, simplification, substitution. This last step could kind of be anything. Okay, let's go to the next one. I love this one, by the way. A rocket is launched with a starting velocity of 5 miles per second. It accelerates at a rate of 4 miles per second squared. What is the rocket's velocity after 7 seconds? Show all the algebraic reasoning to answer this question. The definition of acceleration is acceleration equals final velocity minus starting velocity divided by time. Okay? So they do it with words. We're going to do it with numbers. I'm going to fill in what we know already. So what do we know? We know that the starting velocity was 5. The acceleration is 4 miles per second squared. All right, so the acceleration 4 is equal to, and we don't know the final velocity, so I'm going to call it x, minus the starting velocity. The starting velocity was 5 miles per second, right? Divided by the time. Okay, now it's back to an algebraic equation. Now they want us to do like Kirk did, justify each step. You know, what did we do there? Substitution. Okay, now how do I get rid of that fraction? Notice the 7 on the bottom there, that's a fraction. How do I get rid of it? Multiply by the reciprocal. Okay, or multiply, I'm going to multiply everything by 7. Okay, multiplying everything by 7. Okay, what happens to these two 7s? They basically reduce to 1, and we don't have to write the 1. So they're gone, goodbye. Now we have 7 times 4 equals x minus 5. 7 times 4, we all agree, is 28. 28 equals x minus 5. What am I going to do now? And again, like Kirk would write steps for that. We're not going to do that. Okay? I want to get the x by itself. What do I have to get rid of? The minus 5. Opposite minus, plus. What I do to one side, I do to the other. So the final velocity is 33 feet per second. Squared. Okay, and notice with the symmetric property, I could write it as x equals 33, but that doesn't overly matter. So now let me show you their answer, okay? And we did it a perfectly fine way. Look at their answer. They back everything up, but they used the words. I think that just makes it a little bit more confusing. That's my opinion. Hang on a second, okay. So they back everything, they back everything up with words. But if you notice, they end up pretty much doing what we did. I'm just making this smaller so you can see it on one screen. And notice they got the same thing. 33 miles per second is the velocity, the ending velocity. Okay? So we just did it a slightly different way. They multiplied both sides by time, getting rid of the fraction. So they have time times acceleration equals final velocity. And then they added in starting velocity. We're just not doing that. We're not overcomplicating stuff. We're not. Okie dokie, I took a little pause to see where we were. Okay, check it out here. The measure of angle CAB, sorry about that, is 3 times the measure of DAC. So look, CAB is 3 times the measure of DAC. What is the measure of CAB? If the whole thing is 52 degrees. All right, so watch. Hello, beach ball of death. Okay, so the whole thing is 52 degrees. Okay. I'm just writing that over here somewhere. Now, what do I know about angle DAC? I don't know anything about it. It's an unknown. I'm going to call it X. Okay, and this one is 3 times the size of X. So 3 times the size of X is 3X. All right, and then they add to 52. So we have X plus 3X equals 52. Right, then we have combined like terms. We have 4x equals 52, x equals 13. Okay, but now did we solve the problem? We did not. We have to find out what 3x equals, right? Because they wanted this angle. So what's 3 times 13? Anybody know? 39. So, and what's 39 plus 13? 39 plus 10 is 49. 49 plus 3 is 52. So go us. Okay. Hello. Hello. There we go. All right, so we're going to stop now, and we'll pick up in a couple of seconds.